how to find the area of an ellipse. Alright, so the first step is to find the semi-major axis, sometimes called the major radius. Okay, and that's the longer part, right? So remember, an ellipse is basically like a funny shaped circle, not a perfect circle, right? One side, one edge or side or end will be longer than the other. Okay, so this is the longer axis here. So we'll call this the major axis. And we need to just find half of that, right? So that's the semi-major axis or the major radius. And in this case, we're going to call it A. All right, so from here, we have a nice problem. Look, it's exactly here. So that's 1, 2, 3, 4, 5, 6, 7, 8. So we'll call that A. In most books, most teachers also call that A. All right, then we need to find the semi-minor axis or the minor radius. So that's the shorter end to end. And then remember, once again, we only need the radius. We don't need the whole thing. Okay? And we'll call this one B. And once again, it's very nice. It ends right there. So that's going to be 1, 2, 3, 4, 5, 6. Okay, so we found our semi-major axis, semi-minor axis. And the last step is super duper simple. All we have to do is multiply A times B and times pi. Okay, and then we just write the units. Alright, so in that case, that's 6 times 8, which is 48. They write pi. And in this case, they didn't tell us the units. So I just wrote units squared. Also, if we look carefully, it says leave your answer in pi form. So what that means is, if you forgot or never learned, you just leave the pi. So that's just 6 times 8 times pi, which is just 48 times pi. You just leave it like that. Okay? If they say round your answer, that probably means you have to turn the pi into something like 3.14 and then multiply that out and then do it. But in this case, we can just leave it like that. Okay? And that completes our problem.